So let us solve this problem, that is to estimate the pressure at the center of the earth. Okay, so we are going to estimate the pressure at the center of the earth. So let us consider this is our earth. Let us say this is our earth, okay, and whose radius is capital R. Capital R is the radius of the earth, isn't it? R is the radius of the earth. Now we can consider this earth to be made up of so many thin shells, okay, very small thin shells. So let me consider this as a let me consider a small shell here, okay. A small shell here, and which is at a distance r from the center, and let me take a small shell and draw this small shell here. Okay, so this shell is at a distance r from the center, and the thickness of the shell is, say, dr. Dr is the thickness of the shell. Okay, so the shell, this is the shell. Okay, the shell is now experiencing force due to this core. Okay, the shell is experiencing a force due to this core. So what is the mass of the shell? So mass of the shell is volume into density. So what's the volume of the shell? That is 4 pi r square into dr, volume into density. This is the mass of the shell. And what is the mass of the core? Mass of the core is this core here has got a volume of 4 by 3. It's a solid, so 4 by 3 pi r cube into volume into density. Okay, this is the mass of the core. And what is the small force between them? The small force is given by capital G, mass of the shell, mass of the core, divided by r square. Okay, so this is the force experienced by this shell due to this core. So what is the pressure then? Exerted pressure. Okay, so let us calculate the force here. So force, let us calculate first the force. Force would be equal to G into mass of the shell, which is equal to 4 pi r square dr into rho, okay, into mass of the core, which is 4 by 3 pi r cube into rho, okay, whole divided by r square. Okay, so into 1 by r square. Okay, this is the force. Now the force per unit area, that's called the pressure, isn't it? So what's the small pressure acting on the shell? The pressure acting on the shell, what is that? That is equal to the force dF divided by area. Area is nothing but 4 pi r square. On this area, force is acting, isn't it? So when you divide this, you will get, how much you will get? The value here you will get G rho square will come, okay, rho square, and then rho square into finally you will get G into rho square into 4 by 3 pi r square will get cancelled, this r square will get cancelled, so you will get 1 r. So r, okay, so here this 4 pi r square and this 4 pi r square, when you divide it, that will get cancelled, isn't it? So they will get cancelled. So 4 by 3 pi r into rho square will come here into dr. This is what you will get, isn't it? So this is a small pressure. Okay, So if you want to calculate the pressure, the total pressure, if you want to calculate uh, at this distance r, okay, at this distance r, if you want to calculate the total pressure, what is acting, that is, the total pressure is nothing but integrating this dp from small r to capital R. So when you integrate it from small r to capital R, you will get g rho square, okay, g rho square into when you integrate this, you will get 4 by 3, so 2 by 3 g rho square into pi into r square minus small r square. This is what you will get. Okay, 2 by 3 g rho square pi into r square. This is the pressure which is acting on this shell. Okay, this shell pressure which is acting on this shell due to this outer region. Okay, at a distance r. At distance r, if you calculate what is the total pressure, okay, at distance r you are calculating. So at distance r, where the shell was there, if you calculate the total pressure at that point, it is because of so many shells being added, okay, from small r distance to, where is it, small r distance to capital R distance. Okay, small r distance to capital R distance. When you add all the spherical shells, you will get the pressure at distance r. So if you want to find the pressure at the center, then put equal to r equal to 0, that is at the center. Okay, so if you want to find the pressure at the center, then it is r equal to 0. So you will get, what will you get, 2 by 3, the pressure at the center. Pressure at the center will be how much? 2 by 3 g rho square into pi into r square, isn't it? This is what you will get, 2 by 3 g rho square pi into r square. This is what you will get in the here you can see that this is the pressure we are getting here, the pressure, see. So 2 by 3 g rho square pi, and when you put r equal to 0, you will get r square, isn't it? You will get r square. So the pressure, if you find the pressure, if you want to find the pressure at the center, if you want to find the pressure at the center, how much it will be? The pressure at the center will be 2 by 3. The pressure at the center will be 2 by 3 g rho square pi into r square. This is the pressure at the center. Okay, so when you calculate this, the pressure at the center comes out to be 2 into 10 to the power 11 Newton per meter square. Okay, so this is the pressure at the center of the earth. 2 into 10 to the power 11 Newton per meter square. This is how we calculate the pressure at the center of the earth. Thank you.